So this one is what we can do by method 1. And method 1 said that if you had the log of something equals the log of something else, then A equals B. It's as if you cancel the logs on both sides. That's not what you're doing, but you can think of it that way. It's what it kind of feels like and looks like. Well, on the left-hand side, I don't exactly have just one logarithmic term, but I can get there. So what do I have to do to write it as one logarithmic term? Quotient rule. So if I rewrote this using the quotient rule, this would be log of x minus 6 over x minus 2 equals a log of 5 over x. Now notice what's going on in this one. I've got the log of something equals the log of something else. It's not written, but it's understood that the base here is what? Good. It's understood to be 10 on both sides. Can someone tell me the equation that I can get to follow this up with? What do I get? Gil? Good. X minus 6 over x minus 2 equals 5 over x. And that's coming directly from this idea right here. All right, you're not canceling the logs on both sides. You're really raising both sides to the power of 10, but you don't need to show that. So these two arguments are equal. Cool. Now what? Now what do we do to solve? In fact, if you multiply both sides by the LCD, that's perfect. And the LCD here is what? What's the lowest common denominator in this one, Kyle? Good. X and x minus 2. So on the left-hand side, x minus 2 will cancel. On the right-hand side, x will cancel. So on the left-hand side, I get x times x minus 6 equals 5 times x minus 2. Now in this step, if you wanted to, you could distribute. I just didn't because I want you to see all the different steps. But if you wanted to, in your mind, distribute and say, okay, well that's x squared minus 6x equals 5x minus 10, that's fine. Nothing wrong with that. Then what? What do you do from there? All right, we'll set it equal to 0. So I'll subtract 5x from both sides, and I'll add 10 to both sides. So we'll squeeze in a plus 10 and a plus 10. What equation pops out of that? X squared minus 11x plus 10 equals 0. Cool. How do I solve it from here? Quadratic. Should I pull out the quadratic formula? No? Factor it? Oh, but come on, that's too easy, right? All right, fine. Factor it, that's fine. So we'll do x minus 6 times x minus 5 equals 0. Oh, wait, sorry. Yeah, I'm sorry, I'm not sure what I was thinking. I was thinking of my one-liner that I wanted to deliver next. So x minus 10 and x minus 1 equals 0. So x equals 10 or x equals 1. We okay with that? And take off 2 points from your exam. You got to check it. All right. I know these are positive numbers, but that's not the problem. What's the concern when you check your answer? What are you trying to make sure that doesn't happen? We don't want to take the log of something less than or equal to 0. So, let's see. Our original problem was log of x minus 6 minus log of x minus 2 equals the log of 5 over x. So let's check those kind of one at a time. And we'll start with 10. If I put in a 10 here, So check x equal 10. I'll end up with the log of 4 minus a log of 8 equals a log of 5 over 10. So if you're just trying to get by with the minimum amount of effort, you can say, okay, well, I think and I hope that's fine. Because you don't end up with the log of any negative numbers. And it actually does check if you play around with it just a slight bit. You get the log of 4 over 8 using your quotient rule is a log of 5 over 10. Why is that true? Yeah, you're taking the log of 1/2 on both sides. So it checks. How about the other one? Well, let's check x equal 1. And the first term I check, I get log of 1 minus 6. Do I need to go farther? It's a negative number. So what I expect in your test and what I said earlier, circle this answer, circle that, but put a slash through it, letting me know that you check and realize that that creates a negative logarithm. So that problem you have to throw out. All right? Good on that one. Anything else? I mean, this is a very typical problem that I would want you to solve on an exam. Yes, sir. 80. All right. Last one of these. So log of 7 plus x plus the log of 8 minus x minus the log of 2 equals 2. These are all base 5, right? Log of 2 equals 2. Can I use method 1? Can I use the same method that I had in the last one? No. Why not? How come I can't use the same one that I used last time? Well, actually, they do all have the same base, sort of. Yeah, this is not part of a logarithmic term. So unless you're comfortable rewriting that somehow as a logarithmic term, you're stuck. You have to use method 1. Now method 2. Method 2 looks like this. You're going to start out with log base a of x equals y and rewrite it equivalently as, and look, it always follows this pattern. The base to this power equals this. A to the y power equals x. So that's what we're going to do. We're going to rewrite it like that. Well, I can't just do that yet. And I can't, boy, if you canceled logs right here, you're not going to get any partial credit. Just, you're making it easy for me to grade. So how can I write this with one logarithmic term? These are your properties of logs. How can I, let's start. Let's just start up here. With these two, what can I do? Tell you what, let me do it kind of the way we practiced a while ago. I'm going to write that as, I'm going to take this negative up into the exponent. So I'm using my properties of logs, basically the power rule, and I'm taking, it's not really written, but it's understood that there's a negative 1 here. So I'll take that negative 1, put it up in the exponent, and that makes it positive here. The reason I did that is because now this is the sum of logarithmic terms. Now, you remember my joke a little while ago here, right? And the idea was to rewrite it, rewrite something that's a sum of logs as a log of a product. Here's another one. Something like this. If you have the sum of logarithmic terms, it turns into the log of the product. Ha 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 ha. All right. Yes, sir. Yeah, yeah. You can use the product and the quotient rule too. Sure. But I'm getting a lot of blank stares, so I thought I'd try and move the needle a little bit. Yes, sir. Yes, ma'am. Yeah. So what this is gonna what's gonna happen here is that this ends up as the product of all of these things, right? And because this has a negative exponent, I can move that into the denominator. So I'm getting the same place you would if you use the quotient rule. So another possibility in doing this one is you use the product rule here, and then use the quotient rule after you use the product rule. You're going to get to the same exact place. So it's just a matter of style and preference, and it's up to you. I'm not going to try and micromanage you. So this is going to become the log base 5. Let me put the 2 in the denominator and then FOIL out the numerator. 56 minus 7x plus x. Can I do both of those together? Minus 7 plus 8. What's minus 7 plus 8? 1. So I'll get 1x, and you don't have to write the 1 if you want. And the last but not least, minus x squared equals 2. Now we've got it down to the log of something equals something else. All right. I don't think you should worry about factoring that yet. What we want to do next is rewrite it using exponents. So try and do that. Try and rewrite this using exponents. Right, as the base to some power equals that. So see if you can't rewrite that. I mean, it's not the prettiest expression, but it's workable. Actually, it does work out pretty good overall. Yes? You can't really multiply by the 2 in anywhere to get rid of it. You're kind of stuck with that 2. So, I mean, you could have left it as times 2 to the negative first, but that's still, you still have that 2 there. You can't clear out both sides by multiplying by 2. You can't multiply into here. But good question. Thank you. Kennedy, what to what power equals what? Good. 5 to the second power equals all that. Good. So it should look like this. 5 to the second power equals 56 plus x minus x squared over 2. So 25 equals 56 plus x minus x squared over 2. Yeah. At this point, you want to multiply both sides by 2. So you get 50 equals, and the 2 is going to cancel here, I'll get 56 plus x minus x squared. How do you want to solve this one? Make it equal 0. Now there's a couple ways you can make it equal 0. How do you want to make it equal 0? You could subtract 50 from both sides, and that would be fine. But let me suggest something. How about if we put 0 on this side? Can anyone tell me why I would want to do that? What's the advantage? Yeah, you get rid of the negative in front of the x squared. It's going to be a lot easier to factor if you have a positive x squared as opposed to a negative x squared. So what I'll do is I'll add x squared to both sides, subtract x from both sides, and subtract 56. So minus 56 minus x plus x squared So I get x squared minus x minus 6 equals 0. And that's a little bit easier to work with. Let's see if I can factor this one correctly. Factors as x minus 3 and x plus 2. So x equals 3 and x equals negative 2, right? Go ahead. Ah, good job. Got to check it. So if we check it, let's see. Well, if I put in a 3 here, is a 3 going to create any problems in terms of giving me a negative number? No. So 3 is okay. What about if I put in a negative 2? Is negative 2 going to create a problem when I put it in either of these expressions? No. So both of them, in this case, check. Now you can check it further if you want, but what we've done is like the minimum that we have to do. We check to make sure that you don't get a 0 or a negative number in these logarithmic terms. Yes, sir? Say again? No, you don't want to cancel that one. If you were to check it, there's nothing wrong with it. We get the log of 5 of 7 plus negative 2 plus log base 5 of 8 minus negative 2 minus the log base 5 of 2 equals 2. So let's check it. That's going to be the log base 5 of 9 plus log base 5 of 10 equals 2. Oh, wait, I forgot the... Oh, so it'd be 5. There we go. Thank you. There'd be a 5 here. So, yeah. Log base 5 of 5. So what power of 5? Well, you know what? Let's bring it together this way. Oh, and I got a minus log base 5 of 2 here still. Equals 2. So this is log base 5 of 50 minus log base 5 of 2. These two can come together as log base 5 of 50 over 2, which is log base 5 of 25. What power of 5 gives you 25? 2. So it checks. You do not have to check it all that way. So one last time, let me be clear. What you're worried about is not a negative number. It's of taking the log of a negative number. And when I put this in here, it didn't give me any negative logarithms. So just hope I'm okay on the rest of it. You can check it all the way through. It will work. But, you know, do you want to take the time and effort to do that on a test? It's up to you. All right, good question. Anything else on that one?